In the stomach, because it's a sac, the muscularis propria has an inner oblique, middle circular, and outer oblique. And you see that in other saculate structures like the bladder. Things have to go every which way. It's a lot easier to line a cylinder or tube with smooth muscle. You only need 2 layers. But when things get saculate or bag-like, you got to throw in another layer. This is an exquisite scanning electron micrograph looking down on the surface of the duodenum. So you can see these finger-like villi coming up here, and these arrows point to the openings of the intestinal glands, which are the invagination. So if you took a pair of shears and clipped out the villi, it would look a lot like the gastric mucosa, where you just have those pits going in. Here's a higher power shot, and you might, you could probably, even though we wouldn't do this to you, you could tell that this came from the duodenum. How so? The Brunner's gland is your big thing. But even if you look carefully, you can see intestinal glands and villi, so you know you're in the small intestine. The Brunner's gland tells you that you're definitely in the duodenum. You can just start to hallucinate the crimson stain of the Panna cells, which are at the base of the intestinal gland, and which, I remind you, are found throughout the small intestine. Here's a nice shot in classic shape of goblet cells, right? That kind of rounded shape. Yeah, it's got to be the ileum. You've got villi, and you've got these Peyer's patches. If you look at this villus right here, you can see quite nicely all those goblet cells, which is kind of what you expect, because there's that increase in goblet cells as you move through the intestine, right? But let's follow this epithelial layer. Goblet, goblet, goblet. And then not so many goblet cells. Definitely no goblet cells right here, but this is still a villus. This is a region where you're likely to find these M cells, or M epithelial cells, or microfold cells. And I think I've got this is exquisite. They can be found, as in here, where if we look by EM at this surface, we'd see them one next to another over this whole region, or singly throughout the intestine. And that's what is shown here. So you've got a simple columnar absorptive cell here with microvilli, and one here. But this cell here is clearly not a simple columnar cell. Look how it's attenuated. So you've got just a little bit of cytoplasm here, and room for lymphocytes and macrophages to come right up and be just, 2 or 3 microns from the outside world. So this cell then will endocytose antigen, fragments, whatnot, that will stimulate lymphocytes and whatnot, macrophages to either present antigen or lymphocytes to become plasma cells, which are going to crank out what? Antibody, but what specific type of antibody? IgA, right? This is that immune exclusion, which is then, by carrier protein, transported back into the lumen of the gut, where it can complex antigen before it even gets into the body. That's what immune exclusion is all about. Same song, second verse, in terms of IgA secretion in tears, saliva, milk, colostrum, semen, vaginal fluid. It all makes sense. All right. Nice shot of Panna cells. If you look carefully, you can see that these granules in them, that's actually lysozyme, so it helps digest bacterial cell walls. There's also a protein called defensin, which is toxic to bacteria also, that these cells secrete. This is an immunostain for synaptophysin, which lights up endocrine cells. So in reality, these enteroendocrine cells, if we added up the biomass of all of them, which occur singly in clusters, would be much greater than the endocrine glands that we're going to discuss next week. All right? And they're important. They secrete things like gastrin, whatnot, that help regulate what's happening in the GI tract. And generally in the intestine, they're found at the base of the intestinal glands. Okay, moving to the large intestine, or the colon, again, a shot down onto the surface. So the colon, cut off the villi and you've got colon, essentially. This is quite nice because these little structures right here represent mucinogen packets that have been secreted by what cell? Goblet cell, right? Which provides that mucus to help lubricate passage of undigested material. So if we look in 2 dimensions, in really a perfect profile where we've cut longitudinally these invaginations, you can see all of these glands. You can see the lamina propria, which is heavily infiltrated. See the number of goblet cells. Remember, if we cut kind of a tangential section here, we end up seeing circular profiles, those little flower-like structures Nigel talked about in his lecture. All about plane section. This is a nice low-power shot, cross-section and longitudinal section of the appendix. All right. In cross-section, even at low power, you can see that there are no villi here. Right. So that would make you want to think, even if you're focusing on these lymphoid nodules, well, you can eliminate ileum. The other thing that helps is that the follicles are found completely circumferential. Remember in Payer's patch, it tends to be clustered on one side. And here's a higher power shot. You can see this crypt, the gland. Here's that circular profile when this is cut like that, and you can see a couple of secondary follicles there. And that's all she wrote. So I will see those of you who want to go over the exam Tuesday morning here at 9.